everybody has one of these, right?
Yes.
The spokesperson has said yes.
Yes.
Self-appointed. Any technical questions or anything before we get into stuff for today? I do want to tell you, since I have everybody in here, the average on that first quiz was almost an 82, 81.9. So that's pretty good. 40 A's, 23 B's, 20 C's, 6 D's, 11 F's. Still a pretty good distribution. I like it. And you guys, one more group has a second quiz to take after class. Everybody else is taking that. So there's a quiz. Remember on factoring, if you haven't done it, it's going to be in the next lab after class. Cool. So anything before we get back into new stuff? Okay. Actually, let's do this. To give us a little motivation as to why we do what we do. Hey. Hey. There you go. All right. So, if I had, we've looked at something like this before, and it was to show you why you multiply by the reciprocal. So it kind of makes sense. If I did have a problem like this, what you got, Jeff? Okay. So let me make this really pronounced. How would you do this? Let me remember, yes.
24 over 5 times 24 over 10?
Yeah, because the way you can rewrite this, if you read this, it says 4/5 divided by 10/24, right? That's what it says. So I write it like that, 4/5 divided by 10/24. And of course, when you divide fractions, you multiply by the reciprocal. And then you just reduce what you can. So here I could reduce right here, right? This would be
12.
Can you reduce anything else? I like it, because if it's across from each other, what are they doing to each other? Multiplying, so nothing would cancel them. So I end up with
48.
48, 25. Cool. Okay. So let me make it a little bit worse. So what if I had this to start with? What you got, Jeff? I don't know, man. Yeah, so what's the difference between this and this? It doesn't look like this yet. If I could put these together, it'll look like this. I could do it the same way. Did you guys see that? So on the top, what do you do? Yeah, it's 6. It wants to be 6, so this guy gets a 3. On the bottom, yeah, this guy is missing a 2 to make it the same as him. So you get 3 plus 4 is 7 over 6 over 8 minus 1 is 7 over 10. Of course, then what can you do? Yeah, 7 over 6 times 10 over 7, then a lot of shit happens. These are dead. Yeah, I like to teach it that way because it kind of makes you feel good. I don't like you die. And then what happens with the 10 and the 6? So you get 5/3. Shabam! Alright, so those are supposed to be easy right now because those are all just numbers in there. And of course, oh, is that right? Let me see. Let me leave it there for a second. We have to learn how to deal with when there's variables there because that happens. All right. So here we go. Oh, shnikes. I try to make it really clear what the main division bar is because that's important. Try to do what you can with this first one here. Let me see who just came in. Who needs? Anybody else need a copy of this handout? There's just 2 people. So the very first thing I would do is now this one's kind of evil. And it's trying to make sure that you realize, yeah. Yes, now you factor it. You maybe could tell what's going to happen here, but the point of this problem is don't make assumptions about what's allowed to cancel. Don't start killing them before you're really sure they're going to kill each other. On the top here, I get x minus 2. What's x squared minus 4?
X minus 4.
On the bottom, what's x squared minus 9?
X minus 2.
So does anything cancel?
No.
No, so technically you could stop right there. If you wanted to, you could rewrite this as x minus 2 squared, and the same thing on the bottom with the 2x minus 3's, but nothing cancels, you can just stop right there. So why is this other one here a little worse? Because it starts off disconnected, right? You can see this is connected on the top and bottom. I can just go ahead and do this. This one I can't really. So I can only do that and multiply by reciprocal when I have a fraction divided by a fraction. That's what the first one said. The second one's got a couple fractions divided by a couple. Oh, shit. So I'm going to make the top a single and the bottom a single, and then I can do it. Now I'm going to show you also a different method, but I like to start with this one because this is the one that actually kind of follows what we do anyway with numbers. That's what we would do. But I'll show you a slightly different method if you might like that one better. So take a minute and try to get the top and the bottom. Try to simplify the top and the bottom separately. So the top is a problem, and the bottom is a problem. So in the top here, we try to catch up to you a little bit. What's this guy missing? He's missing a Y. He's missing.
X.
So on the top, I get
2y minus
2y minus 3x over.
X plus
So now I just got to worry about the bottom. What's he missing?
3y squared.
Y squared. Such a needy little dude. This guy needs x. So I end up with
5y squared plus 2y.
yeah, 5y squared plus 2x all over.
X plus Y squared.
And now I do the same thing I did with this guy. So some of mathematics is saying, okay, if it was here, I would know what to do. It's not there, let me get it there, then I know what to do. So if I rewrite this, 2y minus 3x over xy times, turn you around, and write it correctly, Jeff. My goodness, Jeff. It's good enough for government work. And then, of course, what cancels? Yeah, an x and a y. So the x is dead. One of these y's dies. So what am I left with on the bottom? And what am I left with on the top? Anything cancel? Can it kill a y? They want to die. But they can't. I like it. You did not pass the right to die law on this problem. You could distribute the y if you wanted to, but you really don't have to. All right, that problem is done. If you understand what I just did, beautiful. I'm going to redo that problem in a slightly different way. Okay? And if you don't like this other method, don't pay attention. Look at a wall, look at the ceiling, look at your hand and go, do I know the back of my head? So watch. If I look at all four, oh shit. So I'm going to look at all four bottoms. And again, if you like that first method, you don't even have to watch this. What is this guy missing that everybody else has? He's missing a couple y's, right? So this would be 2y squared over xy squared. Got to give him a y squared. He's missing an x and another y. Again, you don't have to do it this way. It's an alternate method. You guys see that? What's this guy missing that everybody else has? He's missing a couple y's. What's he missing? He's missing another y and an x. So I gave him another y and an x. I gave him a couple y's. What's this first guy missing? The same thing the first guy here was missing, a couple y's. And what's this last guy missing? Just an x. Now watch this. Watch this shit. I can multiply top and bottom of any fraction by the same thing. So I'm going to multiply top and bottom of this by xy freaking squared. Because then it'll just die everywhere. And I end up with 2y squared minus 3xy over 5y squared plus 2x. Now if you look at it, is it the same thing we just got a second ago? Yes, it just has the y distributed for me already. So you can do it either way. Yes, sir. All right. I like it. Got to make a big point out of that, because I always got somebody saying, I like the other way, Jeff. Then don't do this way. Do the other way. They're both mathematically the same. Okay. All right, so you guys try these three down here, if you haven't already. Be especially careful about any whole numbers with fractions. Yes, ma'am? Yeah, of course. Yes. Anytime it looks like it'll make sense to do this, do it. This one, it wouldn't make any sense, because it's not separate fractions. They're already together. Yeah. Yeah, Vince, yes, you're right. Oh, this is under nets. This is. So yeah, right here, these would go there. Now. Oh, yeah, yeah. Looks right. That's what it does. We needed a copy of the. Let me do the first one real quick. Catch up with you guys. I'm going to primarily do it the first way I showed you. If you like the second way, if you ask me, I can show you that way, but I'm going to primarily do the first way. So like, I look at the top. This guy needs x. So on the top, I get 2 minus 3x over x, right? Yep. And here, what's this? What do these guys? What does this guy need? Well, he's got it to us. He needs a 5. He needs 2x. So I get divided by 15 plus 2x over 10x times reciprocal. And what's the only thing that cancels? Yes. You can't reduce these. Why? Why can't you reduce these? Because the 15 is not free. It's part of an addition problem. Division can't break into an addition like that. So there's nothing else that happens. Nothing happens. So you could multiply that 10 if you want to. You don't have to, but some of you guys got 20 minus 30x over 15 plus 2x. You're perfectly fine. Or you could stay at 10 times 2 minus 3x over 15 plus 2x. That's perfectly fine. Either one of those. I think everybody I looked at had one of those two. And some of you guys did it the second way, which is nice. I'm not going to give you extra points for that. You just pick a way that makes more sense. Is that, how are we doing there? Is that, any questions on that first one? So yes, it makes sense. What are these called? These are called complex rational expressions. They're like, have you ever seen the Russian nesting dolls? They're like fraction inside, it's like fracception. Is that too old of a reference still? No? Inception, fracception. I like it. It's for me. All right, so how far you guys got on the second one here? Okay. Give myself some more. You need this one, sorry. All right, let me try to do the second one here. So looking at the top by itself, what's the LCD of 6 and 8? 24. Let me try to show you something kind of neat. I'm just going to tell you this once, and if you don't like it, what is 6 times 8? 48. But what number do 6 and 8 have in common? And what's 48 divided by 2? The LCD. Always works. If you don't like what I just said, oh well, don't do it. So what's this first guy? What number is this first guy missing? What did we just talk about? Were you here a second ago? All right. So you're not wrong in a way if you make them both 48. But you are wrong in another way because it's not the lowest denominator. Yes, sir?
Can't make them both 24?
That's, yes. Were we all here a minute ago?
You
When I said,
I said 4, you said that's wrong.
no, somebody said 8.
Oh.
Yeah, there's a lot of people in the room. I'm not only talking to you, but so this first guy does need a 4. You're right. And and does he need any B's? There's got way many B's. This another guy needs what number? 3, and he needs another B. I like it. Now, most people like this way because you only have to look at 2 fractions at once. The other way, you got to look at all of them at once. So it's up to you. It doesn't matter. So what do I get? Let me just write what I got on the top here so far because there's a lot going on here. I got 4a plus 9b over 24b cubed, and that's still 24b cubed. That tells me it's good. They're both that. What's this on the bottom? What does this first guy need? He needs 4b squared. This guy needs just a 3. So on the bottom I get 20b squared minus 3 over 24b cubed. Now notice something that's really nice with this problem. Those are going to cancel when I flip this dude over, right? So I get 4a plus 9b over 24b cubed times reciprocal And then what happens here, like we just said? You know, these guys cancel. Anything happen between these two? Can you factor this guy? Can you factor either one of these guys? So they don't have a chance to have anything go away, so it's just going to be 4a plus 9b over 20b squared minus 3. The funny thing is, the last one is probably the easiest one in a sense. It's the one that's like the first one we did, right? So we try this one out yet? All right, try that. By the way, on Monday I'm going to give you guys a practice test, and then I'm going to give you the answer key. The test, of course, is on the, what day? 15th? I think it's next Thursday. Yes. Yeah, next Wednesday is Valentine's Day. Yay. This time it's going to suck. Oh. Yes. What? So guys, wait. Go ahead. I can't. Stop. Say again. Oh yeah. You want to see it? You can, totally. Yes. Especially this was nice because they actually have the same LCD. So that second method I did earlier would work beautifully on that. It's kind of screaming for it, to be honest. But if you don't like that method, you don't have to do it. Did I finish saying what I was saying about the practice test? I'll have an answer key on Wednesday, maybe Tuesday, I'll see. And the test itself is next Thursday. Oh, yeah. Tests happen in here. Because I don't want to make 18 different tests. So I just give it to you. Yes, ma'am?
There's not going to be a lab test in the morning for it?
No, there will be.
There will be.
Yeah. It's an excellent lab to be in because then you get help right before the test. Sometimes I cancel the lab afterwards, though, so I can go start grading. We'll see. You guys with me? This one's not so bad because it's only one fraction over one fraction. I can immediately flip the other dude. All I got to do here is either way, I like it. And then what cancels? It's the mathing dead. I like it. No, I like that. That's pretty good. I just came up with that. The mathing dead, though. You guys are like walking dead sauce. Couldn't get past the barn. I don't blame you. It gets better after that, but then it gets worse. Sorry. What are they talking about? And then here, what happens? 1x cancels. So what's left alive on the top? So this is a hard part of this. If you're really messy, you could lose a survivor. You don't want to do that. I'm going to bring them all out of there. And what's on the bottom? 2. And again, you could multiply this if you want to, but it's better to leave it so you can see that nothing cancels. Are you guys all right with that? Yeah. All right. 2 more problems, and then I'll let us out of here a little bit early. I'm going to make some up. We're not really going to the next page yet, but I guess you guys did. I'm going to give you some motivation for the next page. Here's a problem you would have seen in Math 90, or whatever equivalent you took. Now, there always is more than one way to do a problem, but I do it a specific way because it comes right off of what we just did. It comes right off of how you combine fractions. You get an LCD first, and then you do stuff. So the way I like to do these problems is I make all the bottoms the same. Because if all the bottoms are the same, what am I allowed to do in an equation? I can do stuff to both sides, right? So if I can make everything being divided by what? What's the LCD? 10. If everything's being divided by 10, I just multiply both sides by 10. All my fractions go away. So who needs what? This first guy needs 5? 2? He's good. So they get 5x over 10 minus 8x over 10 equals 7 over 10. If I multiply both sides by 10, don't make this 50. That's silly. The 10's dot. You guys see that?
Yes.
And then I get 5x minus 8x equals 7. That's all. The tops stay alive. I killed all the bottoms. So if you make all the bottoms the same, you can then multiply by that, both sides, and they die. Now, some people hear this as, I can kill every fraction everywhere. No. Why was I allowed to do this? Because I have two sides. I have an equation. That's the only time I'm allowed to multiply if I have something on the other side to balance me out. You guys with me? Don't get too excited. You can't just kill any fraction sitting there minding its own business. Fraction died. No, you can't do that. Well, up there, you good? What's up? You had a question, though?
Oh, no, yeah.
You're good? Okay. And then just to finish this out, what do you do?
X. 7 divided by
I like it. That feels kind of nice. Yes, sir.
You want us to write our answer in
Oh, mixed number form? No, you don't have to worry about it. It's not any better or worse, to be honest. So let's try one of these out together, and then we'll head out. If you're going to the lab, just got to walk slow. I'll tell you what, let's do number 2 first. It's a nice one to start with. Do number 2. Let's look at number 2. Now watch. What do you think is the first thing you have to do? Factor, so you can see what everybody's got. So this has got a what? Okay. So he's got those. What's the first guy missing then? I like that. Z plus 4. And of course, this guy's missing a Z minus 4. Okay, now, let me see if you guys can handle this without me having to rewrite all of this. I can multiply both sides by what now? Z plus 4, Z minus 4. If I multiply both sides by Z plus 4, Z minus 4, both sides, good Lord. Okay. Because whatever I do to one side, I got to do the other side. Then these cancel everywhere. So what's left? Z plus 4 plus Z minus 4 equals 8. And that looks so much better. So I get 2Z equals 8, right? Because these go away. So I get Z is 4. Now watch. I like, this is another reason why I want to do this one first. It shows you everything. So do I circle that and move on? No. My problem started with variables on the bottom. What value of Z, or Z, makes the bottom 0, which is something I can't allow? Negative 4 and positive 4. What did we get as a supposed answer? Oh, shit. No solution. The only possible answer makes the original problem undefined. It's not math's fault, by the way. I don't blame you for being a little angry. Math did all this freaking work. He gave me this answer to this shit. It's not math's fault. What did we do? What's the very first thing we did? We multiplied by this. And what is z? 4. So we multiply both sides by 0. You're not allowed to do that. So this is math being very polite and going, dude, the thing you did, you weren't allowed to do it. It's all right. This isn't math giving a shit. This is math being nice. You got to check at the end. Now, we just barely got into that. We'll obviously do a lot more of that next time. Okay. So I'll meet you guys over in the lab. Yeah, once you get the access, you get the online.
I printed it somewhere, but I didn't get it.
You'll let do what? Oh, yeah.
So I know what he did was when he took it was like, here's the equation, and then he broke it down, so this one was this one, and this one was this one, and then he looked at this. He has minus 2 squared, and then he's minus 5m plus e, and then it was 7 or